Hello, ladies and gentlemen, and welcome to Lesson 8, an Introduction to Complex Numbers. Complex numbers are used for many applications in mathematics, in engineering, in physics, electronics, and many other areas of science. And they come from trying to solve this problem, x squared plus 1. Now, in historical times, there's been all sorts of problems that we haven't been able to solve that we had to either invent or discover a new number to help us. So when you think about the natural number system, the natural number system starts at 1 and goes to 2 and goes to 3 and goes all the way up. Notice we could do lots of things in this system. We could do 3 plus 2 and give us 5. And we can do 5 subtract 3 and get 2. But what we can't do is 3 subtract 3. In the natural number system, there is no number 0. So that necessitated the addition of a new number to our number set. The number set would be n sub 0, or we would represent it with a w. And where these are called the natural numbers, these are called the whole numbers. These are also sometimes called the counting numbers. Okay? And this new system was 1, 2, 3, but with the addition of 0. So we get a whole new set of numbers. Well, and again, we can do a lot of neat math with this, and we can also do 3 subtract 2, which is 1, and we can do 3 subtract 3 now, which is 0, but we have a hard time doing 3 subtract 4, say. We don't know what that is. That doesn't make sense with our number system. So we have to invent or discover a new set of numbers, and those would be the negative numbers. And they go on and on and on in both directions, and we call them the integers. And their symbol is I. Okay? So then we developed a new set of numbers, the negative numbers. Well, then time went on, and we came up with a new set of numbers called the rationals. And the rationals are the fractions. But more than that, they're any number that can be written as a fraction. So they're any number that can be written as a over b, where b cannot equal 0, and a and b are elements of the integers. In other words, part of this. So this gives us what we call our rational numbers. Now our rational numbers, let's think about them. This could be a rational number, 2 over 3. Top and bottom could both be from the integers. This is a rational number, negative 5 over 7. 6 is a rational number. It could be written as 6 over 1. 0 is a rational number. It could be written as 1. So that gives us a whole bunch of numbers, and this is called the rational number system, and they have a symbol, and their symbol is a Q. Yeah, I don't know why it's a Q, don't bug me. The natural numbers are an N, the whole numbers are a W, the integers are an I, and the rationals are a Q. Yeah, it has something to do with Latin probably. If I go back far enough, we can find it. Okay, well, there are some numbers that can't be represented as a fraction. We've talked about those already in this course. The numbers that can't be represented as a fraction would be numbers like root 2, root 7, pi, root 17, 2 root 3. All of those numbers cannot be represented as a fraction, where the top and the bottom numbers are from the integers. Yeah, I know what you're thinking. There's a fraction! And yes, it's true, but the top and the bottom are not elements of the integers, are they? Okay, so there's the problem there, kids. So all of these numbers create a different group. We're different than you, we're different than you. And we call these guys the irrationals. Okay, they're the irrational numbers, and they have a gang symbol called Q with a hat on it, just a straight line. So these guys are Q, represents all of these guys together, and these guys who aren't any of these guys are the irrationals. And so what mathematicians did was they married the two of them, dum dum da dum, dum dum da dum. They took all the rationals, they made a union with all the irrationals, dum dum da dum, dum da dum, dum da dum, and they called this union the real number system. the real numbers. Okay, and it's usually denoted with a fancy R, but it's the real number system. And that's how our number system came to be. And once again, how did we find out about these numbers when we were living with these numbers? Well, Pythagoras was one of the first on record. Remember they made that triangle, 1, 1, root 2? That root 2 number had to exist, but it didn't exist over here. So that's how we learned about the irrational numbers. Well, today we've got a problem. Today I want to solve x squared minus, today I want to solve x squared plus 1 equals 0. That's what I want to solve today. So isolating for x squared and taking the square root. And we have a problem. Houston, we have a big problem. Put that into your calculator and you're going to get error. But as we know, calculators are dumb and they don't always know what they're saying. It's not really an error. There is a problem here. Let's see what the problem is. Root 4, think about it for a minute. The square root of 4 is 2. But how did you do it? Well, you looked for two numbers, or one number, multiplied itself so that there's two of them to give 2. Same as 9. You looked for one number such that it multiplied by itself for two of them to give 3. Just the same way, cube root of 8, you looked for one number that multiplies by itself 3 times to give 2. Well, the problem is, that's a problem because it can't be positive 2 times positive 2 because that won't give a negative, and it can't be negative 2 times negative 2 because that'll give a negative, and it can't be negative 2 and positive 2 because that ain't the same number. You see the problem here. And so we are down to inventing a whole new type of number, a number that's underneath the radical. So in grade 10, they just told you that you made a mistake. In grade 11, ain't no mistake to be had. We don't have a number that represents that. We need a new number. Say it with me. We need a new number. We need a new number. You can even write it down. We need a new number. So, and that new number will be called I. And we're going to define it as I equals the root of negative 1, and I squared is going to equal negative 1. And that is by definition. So we can't argue with that. That's just what it is. By definition, I equals root negative 1, I squared equals negative 1, and that's a shortcut for the word definition. And I'll be back with your video to finish off.